disease. Likewise, he didn't like control group number 2. Remember, control group number 2 were people who had no types of heart disease, no types of valvular heart disease or coronary heart disease. Now you wonder, why were these people capped in the first place if they were not diseased people? Chances are they were capped because their doctors thought they had symptoms of heart disease. And maybe the fact they were smokers, or maybe the fact that they were diabetic, or high cholesterol, or high blood pressure, or maybe the fact that their parent had developed heart disease went in the doctor's decision to admit that person for this cardiac catheterization test. And therefore, when we ask this group about smoking, or when we ask this group about blood pressure, we're getting a lot of people saying yes, simply because we have enriched the group, this control group 2, by selecting people who were probably enrolled in this cardiac cath testing procedure because of these risk factors. So to show you an example, these are the 105 cases asking about hypertension in their medical records. 43 of the cases were hypertensive, 62 were not. The odds of exposure among the selected cases is 43 divided by 62. This is control group number 2. 170 people who underwent cardiac catheterization and had negative disease, no valvular disease, no heart disease. 89 of these people, a lot more of them were hypertensive. Only 81 of them were non-hypertensive. Notice there's more hypertension among the controls than among the cases. The odds ratio we get is less than 1. It's 0.63, numerically suggesting that hypertension might prevent aortic stenosis from occurring. That's probably very unlikely. It's either that hypertension might cause disease or maybe not have any impact whatsoever, but it's hard to assume that hypertension is good for you, that it prevents aortic stenosis. And chances are what we have here is a biased control group. We've selected people whose amount of hypertension is greater than what existed in the source population. Therefore, our results are wrong. They are essentially underestimating maybe a true effect that hypertension might have on disease. So that's an example of a selection bias in a case control study. The other type of bias, just to complete the picture, is biases due to the numbers the measurements that we make on people. These are observation bias or measurement biases or information biases as they're referred to. And John Last, in his book, Dictionary in Epidemiology, says, it's a flaw in measuring the exposure or measuring the outcome that results in a different quantity, accuracy of information between comparison groups. So what it refers to is mistakes in measurements. And particularly what we worry about are mistakes that happen more commonly in one group than in another group when we compare outcomes in two groups of people, spam users versus non-spam users. Or when we do a case control study and we're asking about previous diets, more mistakes in the reporting of spam diets among the cases versus controls. So observational biases can occur in any study design, case control, cohort, and experimental studies. They occur after the people are selected, and they pertain to the information you're collecting on these people once they're enrolled in the study. So, and when we think of observation bias, I think you should think of two types. One type is called non-differential, or random measurement errors. The other type is called differential, or non-random. Non-differential means we're making mistakes, but we're making the same mistakes in the two groups we're making comparisons about. So if we're doing a case control cohort study, and we're going to be measuring outcomes, diseases, developing in diabetes in two groups of people, spam users and non-spam users, we might make the mistake of misclassifying a person as not being diabetic when he really is diabetic. A lot of diabetics don't know they have that disease. But if we're making mistakes that are not different among the spam users, the exposed people, and among the non-spam users, in other words, we're misclassifying people, we're making them to the same extent in both the exposed and non-exposed people, then we could say our mistakes are not differential. They're not different in the two groups we're comparing. We refer to that as a random misclassification of people, random errors. If we're doing a case control study, we're looking at cases of diabetes and non-cases, controls. We're asking about previous exposures, about spam use. Well, I don't know what I ate 5 years ago or 10 years ago that often. So chances are when I'm asking people about their previous diets, I'm getting some wrong answers. But if the wrong answers are the same among the disease cases and among the non-disease controls, then that's called, again, another non-differential. Mistakes are not different in the two groups. Differential bias misclassifications are much more serious, and they happen when the measurement we're making about disease might be different among the exposed and non-exposed. Maybe among the spam users, I'm really digging into them and following them very closely and recording every case of disease that occurs without any errors, because I think spam causes diabetes. But the non-spam users are not being followed as closely. I'm making some mistakes. I'm missing some diabetes among them. So here the mistakes are different between the two groups. More mistakes in the non-exposed people than in the exposed people. That's an example of a differential bias. And in the case control study, if I'm asking people about their previous diets, I'm asking the cases and the controls this differently. In other words, I'm asking the cases, people with diabetes, to really rack their brains and think about everything they ate in the last 5 years. Because these people know they've been diagnosed with diabetes. Maybe they're giving me an honest, valid result of reporting of their previous diet. But if my controls are people who don't have diabetes and have no disease whatsoever, they might not rack their brains as diligently to report every time they ate spam in the last 5 years. So what might happen? I might have no mistakes among my disease cases. I might have lots of mistakes among my non-disease controls. And as a result, I have mistakes which are different in the two groups. That's differential. Now, why am I making the distinction between differential and non-differential? Remember, if I went back to the beginning, I said, when we think about biases, what we have to think about is first whether they exist or not. Then we have to think about whether they are strong biases or weak biases. And then we have to identify the likely direction of this bias. Will it overestimate or will it tend to underestimate the true effect of a risk factor on an outcome? Because for observational biases, you can predict the direction of the bias when it's non-differential. So let's look at that first. Non-differential means I'm going to make mistakes reporting outcomes on people in cohort studies, but I'm going to be the same amount of mistakes among exposed and non-exposed people. Or in a case control study, I'm going to make mistakes about exposures, but it's the same for the cases and controls. Let me give you an example of using one of the papers that I read a couple of weeks ago. This was that cross-sectional survey looking at 4 groups categorized by acculturation. And basically what they did is they identified 1,100 Native Hawaiian adults living in these 2 communities. 574 of them, roughly half of them, agreed to be in the study and completed an interview, meaning half of them did not. That opens up the potential for a selection bias. The questionnaire, and so they could be grouped. Oops, I messed up something. Let me see if I can bring this. I might have to go back on. Hold on a second. Okay. Aaron, are you there? Okay.
Hi, Fran.
Uh-oh.
Okay, everyone, I think we're having some technical problems. Just hang on.